Today we'll be looking at an aspect of circular motion, which is horizontal circular motion. In one of our classes, we're able to explain circular motion as the motion that takes place in a circular path through an axis. We also looked at vertical circular motion. So today our emphasis will be on horizontal circular motion. So what do we mean by horizontal circular motion? It is simply the motion that takes place on the horizontal surface. It refers to the motion on the horizontal surface and in the circular path. Let's look at this illustration. Assuming we have this horizontal surface, and if this is the motion, assuming you have a string that is tied to this axis, and this string has a mass m, and is made to rotate or perform circular motion. As it's moving, it moves with a velocity v at each point on that surface. And the weight of this is acting perpendicular to the string. So we can say that the centripetal acceleration AC is v squared all over r, where v is the velocity, r is the radius. And in one of our classes, we also said that the centripetal force can be given as this. This is derived from Newton's second law of motion. And with this, we can say that F as the centripetal force is m v squared all over r. And in one of our classes, we also stated the relationship between linear velocity and angular velocity. So with this expression, we can rewrite the centripetal force as Fc equal to m omega r square all over r. By simplifying this, we can say that the centripetal force is equal to m omega square r. So there are certain things we need to know about the horizontal circular motion. One, in a horizontal circular motion, the angular rate of rotation is constant. The angular rate of rotation is constant. And two, the body is at constant speed. The body performing horizontal circular motion is at a constant speed. And three, the object carries forward the same speed, velocity, and acceleration. Same speed, velocity, and acceleration. That body performing horizontal circular motion carries the same speed, same velocity, same acceleration. So we have a problem here to solve, because in physics Once we look at the theoretical background, we'll look at how we can apply that. That is by solving the problem. And that's what makes physics interesting. A particle is in a circular motion in a horizontal plane. It has angular velocity of 10 pi radians per second at the end of 2 seconds, and angular velocity of 15 pi radians per second at the end of 4 seconds. Calculate the angular acceleration of the particle. This is interesting. Like I always said, you have to list out the parameters provided and the formula you are to use. Here we have the angular. We have two of the angular velocities given. One is 10 pi radians per second. The other one is 15. So this is omega 1 giving us 10 pi radians per second. Omega 2 giving us 15 pi radians per second. And then T1 is giving us 2 seconds. And T2 is giving us 4 seconds. And we're asked to calculate the angular acceleration. Simply, one of our classes, we said that angular acceleration is given as omega 2 minus omega 1 all over T2 minus T1, which you can write as change in omega all over change in T. So in this case, you can say that angular acceleration is given as 15 pi minus 10 pi all over 4 minus 2, which is equal to 5 all over 2 is 5 pi, which will give us 2.5 pi radians, which will give us 2.5 pi radians per second square, because what we are looking for is the angular acceleration.